Good morning, all of you.
Good morning, Miss.
Morning.
Thanks for your attendance. Afla, Ajmina, Ameya,
Present.
Atulya, Drishya,
Present.
Present, Miss.
Jyotish, Karthik,
Present, Miss.
Kavya, Nachiket,
Present,
Neeraj,
Present, Miss.
Rangeet,
Present, Miss.
Vaishnav,
Present, Miss.
Anjali, and Shruti. So 4 have to answer: Afla, Jyotish, Vaishna, and Shruti. Okay. Now, so last class we were discussing about the function of data link control. One of the function of data link control, that is the error control. I have told data link controls generally you can have of two types. One the data link control and the other one is the medium access control. It has functions like the framing, then the flow control and the error control mechanisms. Now you have studied about framing concept, two different types of framing, fixed as well as variable. And flow control, you can have two categories. One is stop and wait and other one is the sliding window protocol. Now, comparing flow control and error control, you are having the error detection and correction process and error control mechanism. And they are doing it by the ARQ mechanism. ARQ means automatic repeat request. That means retransmission of data takes place. Now I have told two different types of protocols, categories in error control. One is the stop and wait ARQ and the other one is the sliding window ARQ. And you have seen yesterday the sliding window ARQs, two different types are there. One is the go back and ARQ and the other one is the selective repeat ARQ. Okay, now Ameya will be summarizing yesterday's class. What is go back and ARQ and what is selective repeat ARQ. Yes, Ameya, you can.
In sliding window ARQ, we can send multiple frames at a time.
Okay.
Efficiency of the media is high.
Okay. Now, what is the difference between go back and selective repeat?
In go back, if there is any change in the data, the remaining data will be discarded.
Okay. Then what happens in selective repeat?
In selective repeat, it will continuously send the data, and if
what happens when a frame is damaged? Yeah, tell.
If there is any loss in the data, that data will be sent later and then will rearrange the order.
The data is not sent later. Now, whenever the receiver is sending an NAK frame, then the corresponding data will be transmitted. Whatever data it has been transmitted before is stored. It is not discarded like go back in. That is the difference. Now, hope you can see the slides. Slides is visible? Yes?
Yes.
Amaya?
Yes, Miss.
Okay. Now, just go through the retransmission strategy. This is the summary what I have told yesterday. In go back and the sender resends all frames starting with one identified in NAK. Also, it discards the frames until the correct one is received. So it is called it as go back N. So if one frame is identified in NAK, now whatever frames is coming from the center side, that will be discarded. And until and unless the NAK, the correct frame is received, they won't be accepting the other data. I mean, if the correct data comes, then they will be accepting that in case of go back N. But in selective repeat, the sender retransmits only the frame identified in the NAK. And you are having receiver buffers to keep what our frames are sent from the sender side after that. So what the receiver will do, they will correctly order all these frames and the retransmitted frames. And then they will be sending it to the upper level. Okay, so these were the differences between a go back N protocol and a selective repeat protocol. Okay, now today we will be studying about a protocol called HBLC. HBLC means High Level Data Link Control. Actually, this High Level Data Link Control or HDLC is a bit-oriented protocol. Where you have studied this bit-oriented protocol? Can anybody answer? Where you have studied the bit-oriented protocol? Recollect and tell me. I have told the word bit-oriented protocol. Yes. Who will be answering? Nachiket. Kavya. Okay. You tell. Framing. Yeah. Yeah. Framing, you can have two types. One is fixed and variable. And in variable size framing, you can have two approaches. One is the character-oriented protocol. The other one is the bit-oriented protocol. And there you have studied the bit-oriented protocol. Okay. Now, what was the thing you studied there? A bit-oriented protocol, you will have a frame structure. Okay. Now, that frames will be nothing but sequence of bits. Now, you will have a flag field as well as you will have a data field. Now, what happens if the pattern of the flag, if it appears in the data? They will be in sequence of ones and zeros. So, you will have a specified pattern for the flag, that is 0, 6 ones and then a 0. Okay. Now, if the same pattern, if it appears in the data, what happens? There you are making use of a strategy. That strategy is called bit stuffing. I hope you remember what is bit stuffing. So bit stuffing is nothing but whenever you are having 5 consecutive ones, you will be attaching a 0. You will be attaching or stuffing a 0 bit along with that. And that happens at the center side. And once you stuffed all those things and once you send it, once it reaches the receiver, unstuffing takes place. So that is the concept of bit-oriented protocol. Bit stuffing takes place in bit-oriented protocol. So this HDLC is a bit-oriented protocol. Now, actually, this HDLC is designed to support both half duplex as well as full duplex communication over a point-to-point or a multi-point links. Now, again, the definition comes. I have told two things. One is half duplex, other one is full duplex, and also point-to-point and multi-point. You have to recollect and tell me what is all this. Now, what is half duplex communication? Karthik? What is half duplex communication? Is Karthik available? Yeah, tell. What is half duplex communication? ഓർമ്മയുണ്ടോ? Karthik? Yeah, tell me what is half duplex? You talk a little louder. See, time is going, make it fast. Okay, who knows that answer? What is half duplex communication? Ajmina, okay, you can tell.
And data is transmitted and received not at the same time.
Okay, you have a sender as well as, or you are having two stations and both the stations can send and receive or transmit and receive, but not at the same time. Okay, so that is called half duplex transmission. Now, full duplex means again both the stations are there and both can transmit as well as receive in a simultaneous manner. Okay. Now, you should tell me what is point-to-point and what is multi-point. Drishya, what is point-to-point connection? What is point-to-point connection? Drishya is there?
Yes, Miss.
Yeah. Tell, what is point-to-point connection?
A link between two stations and are only used by them.
Okay, you have a dedicated link between two stations. Okay, only two stations are involved and you are having a dedicated link between those two. That is called a point-to-point connection. Now, what is multi-point? Multi-point means many stations will be sharing a common link. Okay, so HDLC is the type of protocol that supports this multi-point as well as point-to-point links, and they are involved in the half duplex as well as the full duplex transmission. Okay, now this HDLC, it implements the ARQ mechanism. ARQ means the automatic repeat request mechanism. Now, in this protocol, you can have different station types. That means whichever systems are using this HDLC protocol, they can be characterized by three things. Characterized by their station types, by their configuration, and by their response modes. So three ways you can characterize if a system is using an HDLC protocol. One is with the station types, second one is by their configuration, and the third one is by their response mode. Now, what are the different station types in HDLC protocol? You can have three types. One is the primary, the other one is the secondary, and the third one is the combined. So station types, they are of primary, secondary, and combined. Now, what the primary does is, the primary station, it sends commands to the secondary station. Primary station, what it will do is, it will send commands to the secondary station. Okay, now secondary station, what they will do is, they will send responses. Based on the command issued by the primary station, secondary will send the responses. Now, a combined station, it can both command as well as respond. So, combined station means the station which can both send as well as, which can send command as well as responses. I hope the difference is clear. So, station types, primary, it sends the commands, secondary sends the response, and combined, it can both command and response. Okay, so these are the station types in HDLC protocol. Now, next is you can have configuration. Now, configuration means it is the relationship of hardware devices on a link. How the devices are connected on a link. So you can have three different configurations in an HDLC protocol. One is the unbalanced configuration. The other one is the symmetrical configuration. And the third one is the balanced configuration. So three configurations: unbalanced, symmetrical, and balanced. Now, what is this unbalanced configuration? So unbalanced means one device, you can see in the diagram here, one device is acting as the primary and others are the secondary devices. So I told what is the difference between primary and secondary. Primary, what they can do, they can issue command. Now secondary station, what they will do, they will issue responses. Okay. So what in an unbalanced configuration, the primary can send commands. It can be a point-to-point or a multi-point connection. Okay. So if two devices are involved, you can call it as a point-to-point connection. If many devices are involved, you can call it as a multi-point connection. So in unbalanced configuration, one device is acting as the primary and the other one is acting as the secondary devices. Okay, so the primary is controlling the secondary. So primary is issuing the command and the secondary is responding to that command. Okay, now the other type of configuration is called the symmetrical configuration. Now, what is this symmetrical configuration? So symmetrical configuration, here you have physical station. You have one physical station. Okay, so that one physical station on a link, it consists of two logical stations. You can see in the diagram, I have just represented one physical station on a link, and that link, it consists of two logical stations. Okay, in that two logical stations, one is acting as the primary and the other one is the secondary. Okay, so similarly, you can have on the other side also two logical stations. So you just see the diagram. When two devices are involved, they are connected. One is acting as the primary and the other one is acting as the secondary. So primary, they can issue command and secondary can respond. Okay, similarly, the other type of, the second logical station, what it is, one is acting as the primary and the other one is acting as the secondary. So whoever is the primary device, they can issue the command and the secondary can give responses. Okay, so it is like an unbalanced configuration. Okay, except that the control of the link is shift between two stations. It is same like that of unbalanced configuration, but you are having the control. The station who is having the control, they will be sending the command. Okay, so the first type of configuration is the unbalanced configuration. I hope it is clear. And the second type of configuration is the symmetrical configuration. Now, what about the third type of configuration? That is called it as the balanced configuration. So balanced means the both station you are having only a point-to-point link. So HDLC in balanced configuration, it won't support multi-point connection. You are having only a point-to-point connection. Okay, and that is of combined type. Now, what is combined? Both the station can send as well as send command as well as responses. Okay, so HDLC does not support balanced multi-point connection. It supports only balanced point-to-point connection, and the stations are of combined type. Combined type, I have just told, both the stations can send command as well as response. Okay, understood this one. What is HDLC? HDLC is the high-level data link control protocol. It is the bit-oriented protocol which supports full duplex and half duplex communication in a multi-point as well as a point-to-point link. Okay, you can have three types of, three ways the stations can be connected. One is the, one is the, one is the main, which one is the combined one? And the one is acting as the primary, the other one is acting as the secondary. So primary stations can issue commands, secondary can only respond, and combined, you can both command as well as respond. Now, you can have three different types of configuration. One is balanced, unbalanced, and symmetrical. Okay, is it clear? The two things, the station types as well as the configuration in an HDLC protocol. Yes or no? Neeraj? Okay. Now we will move on to the modes of communication in an HDLC protocol. Modes of communication. Modes of communication means it shows the relationship between two devices involved in an exchange. Now, who is having the control over the link? So that is the meaning of modes of communication. Mode means it describes who is having the control over the link. So HDLC, it supports two modes of communication. One is the normal response mode and the other one is the asynchronous balanced mode. Modes of communication, you can have two. One is the normal response mode, the other one is the asynchronous balanced mode. In short form, you will call it as NRM and AB. Now, what is this normal response mode? So, normal response mode, the stage, what type of configuration is that? What type of configuration you are seeing in that diagram? Is it a balanced configuration or a symmetrical configuration or a unbalanced configuration? Who will be answering?
Unbalanced.
What about the station configuration? Yes?
Unbalanced.
Who told now? Yes, it is an unbalanced configuration. So that means one is acting as the primary and the other one is acting as the secondary in a point-to-point connection. Okay, now what about in multi-point? One is acting as the primary again, and whoever is acting as the secondary, they issues the responses. Okay, so this is the already the station types, the configuration, everything you have studied. So that type of communication is called it as the normal response mode communication. So in normal response mode, the station configuration is unbalanced. Okay, that is the first thing. You can have one primary station and multiple station. What the stations can only respond. Now it is used in both point-to-point as well as multi-point links. Okay, so this is the first type of mode of communication in an HBLC protocol. Now, the second one is called as the asynchronous balanced mode. Asynchronous balanced mode, what type of configuration is this one? Tell me. What type of configuration is this? Balanced mode. The configuration is balanced, means the link can only be point-to-point link, where both the stations are combined type. Combined type in the sense both can send command as well as respond. Okay, so you can change the link is point-to-point and each station can act as a primary station or a secondary station. Okay, understood? So I have told the different station types, the configuration and the modes of communication in an HBLC protocol. Now the next one is you can have three types of frames in an HBLC protocol. You can have three different types of frames in an HBLC protocol. In that, the first one is called as the I frame or the information frame. The second one is the S frame or the supervisory frame. And the third one is called as the unnumbered frame or the U frame. So you can have three different types of frames: I frame, S frame, and U frame. Usually this frame format of HBLC will be asked for the exam. So you have to just remember how this. Now, when you are considering each frame, you can see different fields. Okay, you can have a flag field, you can have an address field, control field, a user information field, an FCS field, and a flag field in an I frame. And where the difference comes actually, S frame is nothing but a supervisory frame. It consists only 5 fields. One is the flag field, address field, control, FCS, and flag. But U frame and I frame, you will have use information in the I frame, and U frame, you will have the management information. Okay, there is only a difference between the different types of frames. Now, I frames, now what is its importance? I frames or the information frames, they are used to transport data and control information to the user data. Whatever, if you want to send some user data or the data as well as the control information, you are making use of this I frame. Okay, now S frames are nothing but they are primarily meant for flow and error controls. Already you have seen what are flow controls and what are error controls. So supervisory frame are used to transport control information primarily the data link layer, flow and error controls. Okay, now the third frame, that is called it as the U frame or the unnumbered frame, they are meant for system management. If you want to transfer or transport some management information, you are making use of this U frame. Okay, it is intended only for managing the link. So these are the three different types of frames: I frame, S frame and U frame. Okay, now the beginning of each frame, it starts with a flag field. Now the flag that is used in an HBLC protocol, it is an 8-bit sequence with a bit pattern. Already you have seen, this is a bit-oriented protocol. So what will be the pattern of the flag? What will be the pattern of the flag in a bit-oriented protocol? It is 0, 6 ones, and then a 0. Okay, now this flag fields are used both at the starting of the frame as well as the ending of the frame. Okay, so this is the field, it is an 8-bit sequence and it is used to denote the starting of the frame as well as the ending of the frame. 8-bit means 0 starting with 6 ones and then a 0. Okay, now what about the address field? I'm telling about the I frames now. So all the frames, the similar information is there. Now I frame, what is the address field? What it contains? The address field. So the second field is called as the address field. It contains the address of the secondary station. If the primary station has created the frame, then the address is of the to address. Now, if the secondary creates the frame, it consists of the from address. So now the length of the address field, it can be of 1 byte or several bytes. It can be made, the maximum is 1 byte or it can be of several bytes depending on the need of the network. Depending on the need of the network, the size of the address field can be 1 byte or more than several bytes. Okay, so with 1 byte address, you can identify approximately 128 stations. You can approximately identify 128 stations. Okay, so address field is the second field of the HBLC iframe. It contains the address of the secondary station. If the primary station is creating the frame, means it consists of the to address. And if the secondary is creating the frame, means it consists of the from address. Now the third field is called it as the control field. Now the control field is a 1 or 2 byte segment. Okay, it is meant, I just told, it is meant for the flow and the error control information. Okay, so I'm just telling only the control field of one frame, I frame. Now what is the control field of this I frame? You can just see in the next slide. See, I'm considering an I frame and what are the control fields. There you can see in the diagram, the first bit it starts with 0, then you have 3 bits that is represented as N of S, then you have P by F and the rest is N of R. Now what is all these things? So this is the control field of I frame. So if the first bit of the control field, if it is 0, that means that the frame is of an I frame. It is an information frame. Understanding? If the first bit is 0, then it denotes that it is an I frame. If it is some other frame, so that is important, is I frame, so the control field, you can just note down. Okay, now the next 3 bits, it define the sequence number of the frames in travel. So whichever frames are in the window, that is represented in the next 3 bits. So N of S means it is the value that corresponds to the value of the control variable. Yesterday, you have studied in the error control, the control variables, S, SF and SI. So here S means it is you have studied in the ARQ mechanism. So it is the value of the control variable. Okay, now the next bit is represented as P by F. P by F means it has only one meaning when it is set. The meaning is P by F, that field, if it is 1, you can have some meaning. So P stands for pole and F stands for final. So if pole means if the frame is sent by the primary station to a secondary station, then it is called it as pole. Now if it is called as final, if reverse happens, that is when a frame is sent by a secondary to a primary. So the value will be always equal to 1, and it can denote a pole function or an F function, so, or a final function. So pole means primary to secondary and F means secondary to primary. Now the next 3 bits are nothing but it is denoted it as N of R. N of R means it corresponds to the value of acknowledgement. So similarly, you can have control fields for all the frames. Only I frame I have just told. That similarly, you can have control fields for S frame and U frame. Okay, now when coming back to the I frame, I have just told the control field. Now you are having the user information. Now FCS stands for frame check sequence. FCS stands for frame check sequence. Now actually this frame check sequence, it is an error detection field. It can be 2 byte or 4 byte. So FCS is mainly for error detection, and then it ends with the flag field. Okay, so very, very important, the frame format of HBLC protocol. You can have 3 different types of frames. One is the I frame, then S frame, and the U frame. I frame, information frames, they are used to transport data and as well as some information, control information relating to the user data. Okay, now S frame are nothing but supervisory frame. They are meant for the flow as well as the error control. Now the last one is the U frame or the unnumbered frames. They are reserved for management purpose. Okay, so information carried by the U frames is intended for seven field, address field, the information, FCS and flag. Okay, understood this much? What is an HBLC protocol? Yes or no?
Yes, Miss.
Yes, okay. Now, I'm winding up today here, and I have told a quiz you will have to conduct it. Can you spare me 10 minutes after 1:30? Because you won't be able to finish it now, because the next hour will be disturbed. I thought of completing by 10:45, but I couldn't. So can you spare 10 minutes at 1:30? If you can spare, you will be finishing it off by that time. Yes. Everybody? Yes or no? Afla Ajwina, what is your response? Yes, okay. So after the 5th, 6th hour class, I'll be online. So be online for 10 minutes because you have only 10 to 12 questions. You can easily answer that. And you have to open your Linbase. I have just uploaded the quiz in Linbase and you have to answer there. Okay. I have not unlocked it. I will unlock it at the 6th hour only. So that time you will be able to visible that. Okay. So let me summarize today's topic. We were dealing with a bit-oriented protocol that is meant for half duplex as well as full duplex communication in a point-to-point as well as a multi-point link. That is nothing but the high-level data link control protocol. You can have the different modes of communication. One is the normal response mode and the other one is the asynchronous balance mode. You can have different types of stations, primary, secondary, and combined. And configuration, you can have a balanced configuration, an unbalanced configuration, and a symmetrical configuration. Now, you can have the frame structures for HBLC protocol, 3 different frame structures. One is the I frame, U frame, and the S frame. Okay, now you have got different fields in each frames, iframe, you have a flag field, you have an address field, you have some user information, a frame check sequence mainly for the error detection part, and ends with the flag field. Now control field, it is varying for each flag. For I, S, and U, you have different control fields. If the first bit is 0, you have to identify it as an iframe. Now you can have the other different fields like N of S, N of R, as well as P by F. Okay, so this much is there. Now, next class, I'll be starting with error detection. Have you studied cyclic redundancy check and all in any other subject? CRC code? Yes or no?
No.
No. Yes or no?
No.
No. Okay. You know binary division?
Yes.
Yes. Okay. Just go to revise it, recollect it, and come for tomorrow's class because you are dealing with binary division on that. So you have to just do an example if time permits. So just understand that concept and come for the next class. Okay. So I think for 3 to 4 hours, I will be completing module 2. So today for the quiz, I have kept the transmission media part as well as the flow control part. I don't know how many of you have read it. And yesterday, 4 students have called me and I have told my review on their writing in unit test as well as their assignment. And today, the next 4 has to call. Next 4 means from Drishya. It starts with Drishya, then I think Jyotish, Karthik and Kavya. So you have to call me after 7 o'clock. So that time I will be telling what was your corrections in your unit test. Okay. So next exams will be coming. So side by side, parallelly, read the textbook, prepare your own notes and understand the concepts. Okay. So very, very important, data link layer, data link control functions we have studied, and after error detection, you are going to study the second function, that is the medium access control. That is also very, very important. Second module is a little bit vast because it consists of, you are going to study about 2 different layers. One is the physical layer as well as the data link layer. Now, you want to ask me something regarding the anything? The PPT daily, I am sending it through your Linbase. Are you seeing it or not? PPT as well as the daily YouTube videos I am uploading in Linbase. So if anybody has missed, yesterday 3 were absent in the class. So if you have missed the class, just go through the website, Linbase account and you can just visible the videos, what it has been covered in that missed class. Okay. And Afla is present.
Yes, Miss.
Jyotish
Yes, miss.
and Vaishna and Shruti. Vaishna is there.
Vaishna is absent, Miss.
What happened to her?
She's had exam.
Oh,
Supply exam.
supplementary exam you have got. Okay. Anjali is there today?
Yes, ma'am.
Okay. So Vaishnav, Anjali and Vaishnav were absent yesterday. So you can just go through the videos. If you have any doubt, you can call me.
Vaishnav. Hello.
Yes.
Vaishnav.